Welcome to homework.
Okay, so we need to figure out how many covalent bonds will be drawn to phosphorus in PO4 3 minus. So recall that phosphorus is in group 5A on the periodic table, which means that phosphorus will bring 5 electrons to the party. Oxygen is in group 6A, so if we've got 4 of them, we should have 4 times 5 equals 20 electrons as a result of oxygen. And don't forget that we've got our -3 charge, which will add an additional 3 electrons. So total, we've got 28 electrons to work with. Oh, I did something wrong. That's 6 electrons for each oxygen, which makes this 24 electrons for a total of 32 electrons. Okay. Now, phosphorus is the least electronegative of all the atoms we have present, so that should be the central atom. And we know we've got 4 oxygens, and so we'll just start by drawing a skeletal structure with phosphorus with 4 oxygens. Okay, this is where I like to start, and then consider how many electrons we have left out of that 32. So we've used 8 electrons in building these 4 single bonds, which means we've got 24 electrons left to distribute. Okay, we'll set that aside for now, and I want to discuss something else. Recall that because phosphorus is in group 5A, it wants to see 5 electrons. Now, in some sense, it's going to see 8 electrons due to the octet, right? But if the phosphorus is going to be neutral, which is fairly likely given that it's the least electronegative atom, then it needs to see 5 electrons in the sense that you count each bond as seeing 1 electron per bond, and that each lone pair, if it does have any lone pairs, will count as 2 electrons, right, per lone pair. Okay, so if we want phosphorus to be neutral, which I'm saying is probably the case because it's the least electronegative, so if the negative charge is going to be anywhere, it's on oxygen, then we probably want this phosphorus to have, the 4 1 electron bonds that it's seeing right now, plus some number of additional 1 electron bonds and or lone pairs to total 5. As it were, given that it's already seeing 4 electrons between the 4 bonds that it has, then if we added a lone pair, it would be seeing 6 electrons and we'd have phosphorus negative, right? So I can tell already that we don't want to have any lone pairs on phosphorus. What we want is to have 5 bonds on phosphorus. And given that we've only got 4 oxygens, that means one of them should be a double bond. So this is where I'm going to start now adding lone pairs to everything, right? So I have got, after adding that additional double bond, 22 electrons left to work with. And the most reasonable place to start is often just adding lone pairs to everything, right? Until they have a full octet. So I'm going to start doing that. So there's 6. Now we've got 12. Now we've got 18. And we've got 4 electrons left to give this oxygen 2 lone pairs. So that's all of the electrons counted for. At this point, we can basically just figure out what the charge on each atom is. So oxygen, being in group 6A, right, means that when we're considering its charge, it wants to see 6 electrons in its valence electrons, using the math where we count each lone pair as seeing 2 and each bond as seeing 1. In that case, I see 2 electrons from its bonds, and I see 4 electrons from its lone pairs to give 6, right? And that's that electron, which would make that oxygen neutral. If we do that same thing with these oxygens that have 1 bond and 3 lone pairs, we get 1 plus 2, 4, 6 equals 7. 6 equals 7, which is 1 more than the 6 A in that, oxygen being in group 6 means it wants to see 6 electrons to be neutral. So if it sees 7, that means that these are negative oxygens. They're 1 minus. So minus. And these 3 oxygens are all equivalently -1 or minus, right? And that seems to work out, right? We've got 3 negative oxygens, which gives us the overall negative charge of 3 minus. Recall that we're working on PO4 3 minus. So this seems like a reasonable structure for the phosphate ion.